Okay, factorial notation is where I'm timesing a number by everything underneath it. So, say for 10 factorial, it would be 10 times 9 times 8 times 7, all the way down to times 2 times 1. There's a button on your calculator, and I'll bring up, it's here. So if I went 10, too many, factorial, it will give me what 10 times 8 times 9 times 9 times 7 times etc. is. And if I went 12 factorial, I get 12 factorial. Now, a permutation is the P button on the calculator, and it's useful for finding exactly what we did up the top there. So here, if I said 12P3 and then went 12, where's the P here? I'll get the same answer. And what it actually does is it says it's 12 factorial over 9 factorial. Because 12 factorial is 12 times 11 times 10 times 9, etc. factorial over 9 factorial, and that gives me what I had to start with. So the P works out these ones where order is important. I don't use the button, I use the brackets. So if I wanted to work out 8P3, it's 8 factorial over 5 factorial. Or I could have gone 8P3. 336. Find the number of arrangements, 4 digits, that can be formed, number of 4-digit numbers that can be formed from if they're only used once. Well, I'm drawing up these because it's going to be more helpful for me. 10, 9, 8, 7. Now, why would I muck around with the P button when I can just times that out? If I was going to muck around with the P button, it's 10 and I want 4 of them. How many of these digits are even? Half. Because the last number, there's half a chance of it being even and half of a chance of it being odd. So it's always a half, that question. Okay, I'll come back to this.